We were discussing about the language model, and we saw a toy example also yesterday with a few set of sentences, maybe like three sentences, the starting of the sentence with the end of the sentence, and there were three sentences written as I am Sam, Sam I am, and I do not like green eggs and ham. So with this, we saw for a bigram modeling, like the probability of wi given wi minus 1 equal to how do we model it, like take it the count of wi minus 1 followed by wi divided by the count of wi minus 1. This is how we try to get, right, we get the probability, likelihood estimate. So now let us try to see with the real world data set, like the real world data set one which we are considering is the Reuters data set. It is a collection of documents which appeared in Reuters Newswire something around 1987, and it majorly uses the multi-class classification of documents. Total number of classes that it used was something around 90, and the dataset contains 54,715 sentences in the version that is already included in NLTK library, and the size of the vocabulary given is like 41,600. So the total number of words, the vocabulary or the total number of words, unique words that were used was 41,600. And some of the examples of the sentences or the phrases like that are available in Reuters data set sentences are like it is given here. You can just go through. Okay, like Defoe said yes when asked whether the report was only a humor, but said he company was not prepared to comment further. The reporting of the February trade data was delayed. Terms were not disclosed. But we must be very careful. And in the first 3 months of 1986, the company lost $150,000. But Crudo said he is taking no new proposals. So let us see with an example the fifth sentence. Let us see, but we must be very careful. For example, let us take this particular sentence and then work it out, like how we are trying to model this. Okay, now the row bigram counts, as we said earlier, that we were saying. I'm skipping the slides, and is it visible to you all? Is it in sync with you all right now?
No, sir.
I have just put up row bigram counts.
No, sir. Here it is visible like a real example. Now, routers dataset sentences.
Okay, you didn't get the row bigram counts till now.
No, sir.
Okay, then let me go a little bit slower. Then it may you may get that link. See, so the row bigram counts for, so we said earlier like it was 54,716 sentences, right? Uh, Out of this 54,716 sentences, uh, we wanted to look into that sentence, like, but we must be very careful. Okay, but we must be very careful. That particular sentence, let us check it, like how we are computing the bigram probability for that. Okay, or like various measures or various parameters, let us take it and calculate it. Like uh, out of the 54,716 sentences that what we have said earlier here, and but we, after but we, how many times it occurred? How many times it occurred? Yes, how many times it has occurred? Is the
60.
slide 60 times? Yes. So 60 times after but we occurred 60 times. I am just checking because whether that slide was visible to you all or not. Okay. And if we see here, after but B occurred 2 times, right? after but very occurred one time. Out of how many sentences? 54,716 sentences. Okay. Now, similarly, after V, how many times must occurred? So it means that if zero occurred, it means that there was no sequence. We are interested mostly on bigram here. Okay. Just we are trying to count about the raw bigram counts. Just only bigram counts, which are row words. For the row words only, we are interested to take it out right now. So, but how many times? So in the complete 54,716 sentences, there was not even a single bigram of but or we bust, must or very careful but, like that, or but and but must or but careful, like that. We did not get even a single. So that's why we represent that one as zero. These are simply row bigram counts. Okay. How many? So the combination of the words, we are just interested in combination of the words only. But but we must be very careful. So and we are just checking with respect to only that words only, unique that words, but we must be very careful. So after but, how many times but occurred? After but we, how many times occurred? After but must, how many times occurred? After but be, how many times occurred? After but very, how many times occurred? So but followed by careful, how many times it occurred? Similarly, we followed by but, we followed by we followed by must, we followed by be, we followed by very, we followed by careful. How many times it occurred? Just we are trying to give it this. Okay, this is the combination of the words that has occurred like that. Now, so let's try to normalize by the unigrams, or let us try to get the row bigram probabilities. So if you wanted to find like what is the row bigram probability for but followed by V, okay, but followed by V. So what is the formula that was given earlier? Yes, what is the formula? Count of, count of,
The previous one with respect to the next one divided by the previous one.
yes, that is. So count of Wi minus 1 comma Wi divided by Wi minus 1, right? That is what we are interested in. So now if you take the row bigram probabilities, but we, so in the previous slide, if you have seen, just to gone through, you must have seen that but we occurred 60 times. Okay, but we occurred 60 times. So this 60 here, this is 60. Okay, this is 60 divided by how much? Divided by how much?
2429.
Yes, 2429. 2429. So this is the value that you are going to get it, 0.0247. This is the probability. This is the row bigram probability. But we. So I hope you are now getting it. So can you please calculate but B? But B. Please calculate and tell me. Similarly, but very. Just a simple thing, please. I'm just going to the previous slide and checking it. But B occurred 2 times, but very occurred 1 time. Okay, but B occurred how many times? One. This is 2 time and 1 time. This is 2 times it has occurred. Okay, this is 2 times it occurred. This is 1 time it has occurred. Then what is the probability of but B?
8.23 into 10 to the power minus 4.
See, but B, 2, simply 2 divided by but 2429. Similarly, 1 divided by 2429. Okay, it is just but B 2 divided by 2429 and very very 1 divided by 2429. So this is what we are supposed to get. Okay, similarly, can you please calculate for all the row bigram probabilities for the complete table? So if you calculate it, you are going to get the table. Is the table visible now with computed values of row bigram probabilities?
Yes, sir.
Okay, please just go through. If you are having any doubts or any clarifications, then we can discuss over it. I hope it's clear, right? So similarly, how do you estimate now? Suppose like that we compute. It means that we are going to compute the table like that for the complete set of words. Okay, how many unique words are there, and then with respect to the all the words, okay, you are going to compute the table and keep it. Now, how do you compute the bigram estimate of a sentence probability then in that case? For example, you give the probability of the best Hindi song of the year. How do you give it? How do you give it now? So you try to give it. So probability of the occurring as the first word given this star represents the first, okay, the start symbol, okay, after the start symbol. So the occurring as the first uh, word, then probability into probability of best given the into probability of Hindi given best into probability of song given Hindi into probability of given song into probability of the given of into probability of year given the. It means that you're interested in finding out the complete set, the best song of the year. So you multiply. So from the Reuters data set, if you take it and then multiply, the value that you are going to get it is 0.00000067. This is the value that you are going to get it. So this is the probability of this sentence occurring. What is the probability of the best Hindi song of the year? So this is the probability. Okay, point six zeros, 6 or 7 zeros. It is 1 2 3 4 5 6 7 7 zeros followed by 6 and 7. Okay.
So can you show it mathematically once, the calculation for this one?
See, for this one, see, we do
Yes,
not have
sir.
the data set right now. So it means that if you have seen, it is nothing but the see this probability into 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 this probability like that. So let us try to see the probability of then in that case, but we must be very careful. Okay, shall we?
Yes, sir.
Yes. So now what is the probability then? What is the probability of occurring that particular word? But we must be very careful. Please computer and give it to me. But we must be very careful. So what is the probability of occurring this as the first word? But what is the probability of occurring but as the first word? What is the probability of occurring but as the first word? Yes. How do we compute that one? But as the first word. It gives that individual probability, computing individual probability. So what is that individual probability now computing? What is that? But as the first word. So it means that how many times but has occurred? 2429, right?
2429.
2429 divided by,
Sum of all.
54716.
yes, yes, this what is this complete, okay.
84,000.
How many? Assume that this is the this is the only data set, but let us actually what we have to do is that the not the sentences but the vocabulary. As I said you that the size of vocabulary is 41,600, right? 41,600. So now 24216, 2429 divided by 2429 divided by how many? How many words? 41,600. Okay, 41,600. What is the value here? Okay, what is the probability value here? So that one into then but v. What is the probability? After but, then v should occur. What is the probability? 0. Just now we calculated 0.0247 into, okay, after v must should occur. After v must should occur, right? After v must, then 0.0188 into must be, then 0.3509 into, then after b very 0.0049 into, after very careful 0.0071. So I hope you got me. Okay, so this is the value. What is the value? What is the value that you are going to get it? Please, can you please compute it and tell me? Please, someone. Yes.
3.028.
3 point you are going to get it.
Yes, sir.
Sir, exponent will be around 10 to the power
10.
minus 9 or 10.
Okay.
Exponent to the power 10, it is like
Minus 10.
So definitely. Okay. So you need to get it like a 0 point after some zeros and all, you are going to get it like that, right? So it is like, what is the value? 2429 divided by 41600. That is you are going to get it. I think the value. What is that value? You are going to get
It's a
it
0.058.
0.058 into 0.0247. Okay, 0.0427. So that leads to 0.001442. Just I am computing in my mobile. Okay, into then again 0.0188 into, okay. So this way you need to compute it, give the complete calculation. So that is the value that what you are going to get it. Okay, this is the value, like the value that you are going to get it. So it will be 0 followed by, so completely you have to compute it 0.3509 into 0.0049 into 0.0079. So what is the value that you got it? Something 3 point. Yes, please
It's a
spell me out.
0.328 into 10 to the power minus 9.
Point 0
328. 0.328
328 into 10 power
10 to the power minus 9. 10
minus
power
9.
minus 9.
9. You see that. See, this is the value. This is the probability for this Reuters data set with the given values. But we must be very careful to means to get this sentence. The probability is computed like this. Okay. So similarly, that was what it is given. Like earlier, that sentence was given. Like, how do you compute the probability? That's why the sentence is given, and using the Reuters data set, maybe like the how many times occurred, best how many times occurred, Hindi how many times occurred, song. So we have to first compute the row bigram counts. Then afterwards, we have to compute the row bigram probabilities. Then only you are going to compute this completely Okay, the summation, sorry, not the summation, the product. Okay, product of the probabilities, and you are going to get it a point followed by 7067. Okay, is it clear now?
Yes, sir.
Okay, fine.
Yes, sir.
So what kind of knowledge that we are going to acquire here? The problem here is that product overflow of values. Okay, like you are going to, maybe like if it is a long sentence, maybe like okay, a sentence with maybe like I am here, or I like, or I want. So this type of words and all, maybe like for a sentence, it may be the probability may be very like computing them may be very easy. But uh, suppose somebody gives a big sentence, a long sentence, you know that there are some people, there is a you have a habit of writing a very long lengthy sentence. So in that case, how computing the probabilities will be, it is like the overflowing or underflowing conditions may occur, and also maybe like the computation of these probabilities will be high. So one of the solutions that we can use it for this practical usage is that you use the log probabilities so that you can add it afterwards. Okay, so like how do we do, uh, suppose you wanted to give it a probability 1 into probability 2 into probability 3 into probability 4, you can give the same thing as log probability 1 plus log probability 2 plus log probability 3 plus log probability 4. This way you can give it, right? P1 into P2 into P3 into P4 can be computed as, or it can be the same. The result is same as that of like a log P1 plus log P2 plus log P3 plus log P4. So this is for the practical approach. Okay, this is the best way that you can try to do. Instead of product, you have to do the summation. That is the thing. Okay. Uh, Now let us see, like the usage also gets varied. Okay, like let me show you. Is it visible from Google Books Ngram viewer?
No, sir.
Okay, see, like Google Books Ngram viewer. Suppose if you go to the Google Books Ngram viewer, this varies also. Please remember that sometimes what happens is like the usage of the sentences varies from maybe like from see, earlier some usage of the words are there. Now the words are not may not be used. So suppose like if you see like the word uh, I am happy. Okay, how in 1800 or maybe like in 1800, how the word usage was there? Okay, what is the sequence of this word usage? And then when it came maybe like down to 1840s and all, the usage of these particular words or maybe like a sequence of words is very less. This is all taken from the Google Books. Okay, this is only taken from the Google Books with the Ngram viewer. Okay, n-gram here, n-gram is 3 gram. I am happy, so 3 gram, right? Suppose some other sentence is given. You tell me a long sentence, one sentence that you wanted to ask. Yes, suppose I wanted to give all students are good. Suppose all students are good. See, you see that basically it was almost a zero probability. Okay, until 1900 plus. Okay, something around 1915 or something. Till then it was zero usage. It means that students were very bad. Huh? Is it so? So it means that there was no usage of the words in Google Books till 1915 something. After that maybe like sometimes it was used, and then how you can see that in 2019 and all. So maybe you can see something around 2003 and all, students were very good. Again students are getting deteriorated. Okay, the usage of the words are getting deteriorated. And 2019, you can see that it is like the probability is 0 point some 7 zeros followed by 134%. Okay, only this much. So similarly, you can compare with like one sentence usage of one sentence with another sentence also. Like uh, boys are good and girls are good. See, there is a sentence that so earlier you see that we used to say that like in 1800 and all, maybe like the usage of the words. See, this is only just some examples I am drawing. Please don't think that anything else. Okay, like or I do not want to deteriorate anybody or something like that. Okay, please see, if you see in 1800 and all, the words like the usage of the words like girls are good was very high. Okay, that red line, red mark, is it visible now?
Sir.
Yes, sir.
Yes, sir.
Yes, yes.
Yes, sir.
Only girls are good. 1800 I told girls are good, so then they are replying. What about boys? When you come back to 2019, boys are good now. If you see here, right, boys? Any boys are here in this class?
Yes, sir.
One
Yes,
boy
sir.
is there at least. Okay, so many boys are there. By 2019, boys become very good. Huh? How come it is happening like this? You tell me some other sentence. Let me compare and show you.
COVID vaccine.
COVID vaccine. COVID vaccine will not, may not be there. COVID vaccine. Ah. See, it is not there. It is not at all. It was not until 2019. Google Books. It's not at all used. Okay. It's showing no valid n-grams to plot. So anything else? Any sentence?
Sir,
So
Ah.
life is good, life is bad.
Life is good. Life is still, or life is bad
So life
versus
is good, life is good.
life is good. Okay. Dekho. Life is always good. Huh? Life is becoming bad. Maybe like the probability of usage of the words in 2019 is high. Okay, life is bad. Life is good. Also, the probability of usage of life is good is also high. Okay, it means that there is a huge gap between good and bad. You can see here. Anyway, see, this just I wanted to show you like how the usage of the words based on this one also, like it is not like this is standard. What I say is that, see, like the best song of the year, the best Hindi song of the year, this is like if I say that, okay, the best Hindi song of the year, it means that always it is not true that you should be getting that particular probability, right? It depends upon the data set what you are using, but the data set varies again. See, in 1800 the data set was something different. Okay, and you see, like in the slides, when coming back to slides, if you see here, okay, the uh, three sentences are compared here. You see here, how often did, and how often did you. Okay, if you see how the n-grams with respect to different n-grams, or with respect to the usage of the words, how it changed. Okay,
sir,
getting
I had a
me?
question.
Yeah, please.
Here, how much is n in n-gram?
Where
I mean,
uh,
this is an
where you
n-gram
are,
here, so how much is n here?
where?
This Google Books n-gram viewer, how much n we are using right now?
See, no, it is not like that. It depends upon how much you can use it also. It doesn't matter.
But
Okay,
for this particular graphs, how much n is being used? Is it bigram, trigram? What is n here?
no, here what n-gram viewer means, what you have to understand is that For that, see how often if you use it, the n-gram is 2. How often did if you use it, the n-gram is 3. How often did you, the n-gram is 4. Different n-grams. So you need to understand what I'm interested in telling here is that, or what is my intention is telling is that, what is the possibility of usage? Okay, if you use how often, it means that how often is generally used. Okay, how often, maybe like followed by all, is how you are using it, or how often when you are telling it, how often you are giving it. It means that what is the possibility of usage, that one. And it is a 2 gram. How often did, then it is 3 gram. Okay, in this graph it is not with a single gram, a single n gram. So here n is, suppose you give a lengthy sentence, the n gram value changes. Getting me? See here
Yes,
3
sir.
sentences are given. You see, like if I give it here, earlier I was giving you one example. Suppose here life is bad. Suppose simply you write it, life is bad. Okay, so I can see with respect to single sentence, that was for comparison. Okay, this is three this one, what is that, uh, 3 gram. Now life is bad, life is bad every time suppose I give it, this is 4 gram. Okay, life is bad is not available basically. Okay, life is bad every time, so it is not. Okay, followed by it is, I should give comparison, means life is bad, you see there. The second one, life is bad every time, is not available, but first one it is available. How it is available? Okay, uh, life is bad here. See, life is bad here also is not available for comparison. Fine, you're getting me. Just please don't think that if I make 10 sentences, then there should be an average of the n grams, or there should be like what is the n gram there, like it should be every it doesn't mean that only when n grams are same, then only it will plot a graph for you like that. Nothing. Okay, getting me?
Yes, sir.
Okay, fine. So this is just my intention of telling is like, even for the complete, you take one data set and you take that, okay, the probability always you will get like how often, or like maybe like the best song of the best Hindi song of the year, or maybe like you give a sentence and the probability will be computed same. No, it depends upon the usage, because the usage is getting changed. Hmm? Maybe like earlier, how you used to speak in English, maybe like hi, maybe like, or you used to tell that hi brother, but nowadays you tell it the hi bro. Okay, so the usage of the bro here. Okay, or you maybe earlier you were using only hi, here nowadays you are using hi bro. So the usage of the English has varied. In Oxford dictionary, every time they add some words. Why do they add words? It is because of, as I said you, that adding with like different, when like um, when as time period evolves, like some new words are also getting added into the dictionary. What do we mean by helicopter parenting? Or suppose I tell you that, ask you like, you just understand this one, it's a helicopter shot. Dhoni is specialist in helicopter shot. What do you mean by helicopter shot? The way it flies, okay, the way the bat flies is like that of an helicopter wing fan or something like that. Okay, that is the flight. It means that, see, till helicopter was invented, maybe like nobody knew that this should be the thing, right? Please get me a Xerox. What do you mean by Xerox? What do we mean by Xerox? A duplicate copy, right? Xerox means a duplicate copy. Now, what do we mean by again? See, till when Xerox was not invented, do you think that the word Xerox will be there? Nobody knew it. Nobody knew it that the word called Xerox will be there. Maybe like somebody invented the machine Xerox, Xerox. So the people started that Xerox, Xerox, Xerox. It means that it is a machine which gives a duplicate thing, duplicating of the articles or paper, something like that. Okay, paper duplication. So this is so as time evolves, new words get into new words come into the languages. That's what sometimes the mixture of the languages and all. So this happens. That's why that depends upon the usage. So that's why what I wanted to say is that like you do not get the same probability every time. It depends upon what data set and what is the year of the data set that you are taking into consideration. So always you have to take it the latest data set also. Okay, fine. Anyway, so Google Ngram release was done in 2006 and it was given by posted by Frank and Brands uh, uh, from the Google machine translation team, and they have given for the research, and they have given like the counts are something. So they processed something 1 trillion words of running text and are publishing the counts for 1 trillion plus. Okay, 1 trillion 176 billion 470. Sorry, not this. 1 billion, 1 billion 176 million 470,000 663 5 words sentences that appear at least 40 times, and there are 13 million plus unique words after discarding words that appear less than 200 times. This is the thing, and some of the examples of this 4 gram words in Google ngram release was like serve as the incoming, which occurred 92 times, serve as the incubator 99 times, serve as the independent, like this, serve as the index, serve as the indication, indicator, indicators, indispensable, indispensable. Okay, then individual, like that. Okay, how many times it has occurred, it is being given here, examples only. Okay, ngram data and like this corpus of contemporary American English data, it is given here. Okay, just like showing, and this data is available with the linguistic data consortium of the University of Pennsylvania, and they are having approximately 1 trillion word tokens, and ngram ranges from unigrams to 5 grams, up to 5 grams they have given here. So generating sentences from ngram models, how do we generate it? So it is like if you take a Shannon visualization method, the Shannon visualization method says like this, like choose random bigram. Random bigram means the start word, sorry, the start symbol followed by some word. Okay, any word, random word. Okay, any random word you can choose it. So that's why. So initial probability for occurring that particular word initially we calculate, right? So here start followed the start symbol followed by a word. So this is, let me give you here. Okay, the start symbol followed by a word according to its probability, then you multiply. Next, another, choose the random bigram, this word w. Okay, this word w followed by some other word. Okay, maybe like a w followed by x. Here it is given w followed by x. Okay, then multiply with that one, and you do the same, x followed by something, some other word, y followed by some other word, z followed by some other word, like that, like that you have to do until the end of the sentence symbol is attained. Okay, now the string, then string the words together. So you multiply, that is what you are trying to do it here. So here you see I, okay. For example, I, then I want, then I want to eat Chinese food. So and food followed by the end of the sentence. So the complete sentence that you generate here is that I want to eat Chinese food. Are you getting me? How to generate the sentence? Now,
Yes, sir.
yes. So if you take Shakespeare works, the works of Shakespeare as a corpus, then n equal to the number of total tokens, okay, is 884,647 tokens, with the vocabulary size as, it means that vocabulary unique words is 29,066 words, and vocabulary produced, Shakespeare's vocabulary produced around, or Shakespeare produced around 300,000 bigram types out of this vocabulary square as 844 million possible bigrams. Okay, 29066 cross 29 cross 066. Okay, and here 99.96% of the possible bigrams have zero entries in the table. You must have seen earlier what we have seen it for the table. Okay, but we must be very careful. There are so many zero entries are there. It means that the combination of those words have never occurred. So here in this Shakespeare's works, if you see 99.96% of the possible bigrams have zero entries in the table. And you see 4 gram would be worse in terms of number of zeros. Okay, this 4 gram, it is said that the 4 grams would be worse in terms of number of zeros. And if you see here, the approximating the Shakespeare's work, like unigrams, some of the words here it is given with the sentences and the words. Similarly for bigrams, trigrams, quadgrams, it is given. And with the Wall Street Journal corpus, it is given like unigram, bigram, trigram, how they have occurred, like what are the sentences, example sentences that have been taken into consideration. Okay, there it is given here the example. So how to evaluate the language model? What is the process of evaluating the language model? So should I stop here, or we need to continue? It is 11:53, so I'm stopping here. Okay.
Hello, sir.
Yes, please.
Sir, I still had a doubt regarding that Google Ngram generator. I was saying
Yes.
that suppose we take a single sentence,
Huh.
and in that sentence, what kind of bigram are we considering at that? Are we considering bigram or trigram in that sentence?